Good morning. I'm at YNU today in the faculty staff meeting room. Okay, it's a bit dark, but today I can use whiteboard. I'm not sure it works well or not, but I'll try. Next week, from next week, I will start the second latter half of this subject class, seismic design. We will devote, I think, only 4 or 5 times on seismic design. So today is the last time to learn durability design. Okay, as I promised last week, construction management, a kind of construction management, which is very important to achieve durable structures. Okay. So I'll go step by step. So if you have a question, please ask me after the end of each part of today's lecture. It's okay? はい。I will start from short PowerPoint file. Okay. All right. Can you see this one? はい。はい。So yes. Today it's one scenario, okay? But I will use several materials, okay? So this is the first one. The PowerPoint file, which I used in ACI forum. It's about concrete sustainability in USA, okay? So I selected this PowerPoint file because you can have general idea about good construction or how we can achieve durable structures. Okay. はい。じゃあ go ahead. The title is revolutionary systems for the construction of long life infrastructures. Okay. はい。Sorry, this was not PowerPoint. はい。Sorry, this is PDF file. So this short presentation consists of 3 parts. I will start the first part. Okay. So I think you have seen the picture of this deteriorated abutment, I guess. Okay. So it's not so clear, but you can find crackings. Honestly, this is after repairing. Okay. So a kind of re-deterioration. Okay. Even after repairing, cracks have appeared again, and you can find a kind of dirty rust, okay, generated from cracking. Okay. So this story was born in small local government. The name of local government is Yamaguchi Prefecture, okay, which is located at the west end of our main island. Okay, Tokyo is here. After establishing their system in Yamaguchi Prefecture, harmful cracks have been well controlled like that. Okay. Actually, I have been involved in this system from 2009, okay, as an outside researcher. I supported their development, and after that, I spread their philosophy or system to whole Japan. Okay. I will tell you about, I will tell you detail about this check sheet, which can be used in your country also, I think, okay? It's called a revolutionary check sheet, okay? And I think you cannot see the details, but you can find it later, okay? In this sheet, in this check sheet, okay, 27 items, something like that, are included. Okay. 8 among 27 items are related to preparation of concreting work. The 9 items are related to placing of concrete, fresh concrete. For example, it's specified in the national code that the height of one layer should be less than 50 centimeters. It's specified in Japanese specification. Okay, but this kind of fundamental matters related to placing of concrete are included in this check sheet. The 5 items among 27 are related to compaction. In Japanese, shimekatame. Placement is dasetsu uchikomi in Japanese. For example, internal vibrators should be inserted about 10 centimeters into the lower layer of concrete. It's also specified in the specification, okay? But it's listed. Something like that, okay? I will tell you how this check sheet will work for construction management. All are very basic matters in concreting work, okay? But revolutionary is not special thing. Okay? It means just to do our work properly, okay? As a construction management. If we do not our work properly, crack will happen and durability will not be achieved. Okay? 当たり前のことは当たり前にやることができれば世の中すべてうまくいくんですけど、そうじゃないので、初期欠陥が生じる、ひび割れがたくさん入る。そこ当たり前のことを当たり前のようにできるようにしていくのがマネジメントだと私は思っています。Okay. According to this system, harmful cracks have been drastically, remarkably reduced, as shown in this graph. Okay? This system was officially launched, started from 2007. Before 2007, in 2 years, they tried to establish a kind of system. Okay? So you can find that the harmful cracks have been drastically reduced, okay, according to their system. The definition of harmful crack in Yamaguchi Prefecture is larger than, equal to or larger than 0.15 millimeter. Okay. はい。So again, Yamaguchi system was officially operated since 2007. Okay. Still now it's being improved. はい。で、how, maybe you will learn how they established this system. Actually, trial construction in actual structures. It's not trial, actual construction. Okay, so a kind of experiment utilizing actual structures were tried. Okay, then finally they developed the system. What kind of crack? I'll tell you later. It's a kind of thermal crack, cracking during construction. Okay. Do you know the cause of thermal crack? Can you explain? I'll briefly explain later. はい。で、this slide shows the system, Yamaguchi system, briefly. Okay. It's a kind of PDCA system. Okay. So today's topic is related to crack control system. Okay. So first of all, crack control design will be done. It's a kind of durability design which you learn in my lecture. Okay. Now I have not explained anything about crack control design. But later you will learn. Okay? Anyway, crack control design should be done first. Okay. After that, construction will be done. If the quality of construction is very poor, okay, all will be gone. Okay, all will be lost. All might be lost. Okay, sorry. So that's why in their system, utilizing check sheet, quality of construction, quality of concreting work was improved. Okay, so based on nice design, based on nice construction, they will observe the result, whether cracking happens or cracking was well controlled, etc. Okay, they accumulate this data step by step. Okay, something like that. Okay, so in their system, they can refer the database for crack control design. Okay. So based on this database or based on their own guideline, they will do proper crack control design. Okay. Something like this is a kind of PDCA system. Okay, I'll go ahead. This is just one example. You can have a kind of image about crack control design. So they plotted their own construction result data, okay, for each structure. Okay, but each structure has its own reinforcement ratio. Okay, some have so-so, for example, for 0.4 or 0.5 reinforcement ratio, but some have very low reinforcement ratio. They have their own construction database, so they can observe maximum crack widths in their own database. Okay, so they plot it. So you can find that the increasing reinforcement ratio seems effective to control crack widths. Okay, again, I already explained that their threshold value, the limit value of crack widths is 0.15 millimeter. Okay, so referring this kind of data, additional reinforcing bars to control crack widths can be added. Okay. etc. Okay. Roughly speaking, this kind of system. Okay, so I must go into detail. Otherwise, now you can have only general idea or understanding. Okay. So gradually, I will go into detail. So do you have any questions? So up to this. State. ちょっと待って、If you have any question, あれちょっと待って。聞こえない。Can you hear me? Sorry, I cannot hear your voice. So, can you hear me?
We can hear you.
Okay, yes.
Yes.
I can hear you. Sorry. Do you have any question?
Yes, Sensei.
Yes.
Yes, I would like to ask questions about the reinforcement ratio. This reinforcement ratio is what kind of concrete structure member? I mean, is a column or a beam or slab or that sort?
I see. This today's scenario is about crack controlling system, but this is abutment, okay, for bridge. This is a section drawing for abutment. So you can see this slide?
Yes.
Okay, this is footing. Okay, of course foundations are below the footing, and this is a vertical wall of abutment. This is parapet. So here girder will come. Okay.
Yes.
Do you understand? So I have shown this kind of example. This is abutment. Okay.
Yes. Yes.
So they wanted to control thermal cracking generated in a vertical wall or parapet part. Do you understand? It's okay?
Yes, Sensei.
Okay, hi. Any other question?
So can we just call them the I section? It just seems like I.
Pardon?
Actually, the structure which you have just shown in the previous slide, can we just go over there?
Abutment.
Oh.
Do you know abutment?
Yeah.
Yes, yes.
So
not
sorry?
dissection, sorry. This one, okay? Abutment is supporting upper structure, okay?
Okay.
Oh.
So say,
Yes.
Yeah, I have another question. My question
Yes.
is this time. Yes, this reinforcement ratio is work for other structure member too, right? That's not just only for this kind of abutment, or it also work for other structure member?
This one? You mean this one?
This reinforcement ratio, yes.
Okay. So this reinforcement ratio means the reinforcement ratio in this section, for example, okay? You can see?
Yes.
Okay, so after these questions, I will tell you about the mechanism of thermal cracking, okay? So reinforcing bars, reinforced rebars perpendicular to cracking are effective, okay? That's why, but for example, if we think about abutment, if we think about crack control in abutment, the reinforcement ratio of these bars, for example, these bars, which are perpendicular to cracking, are effective. That's why not so large reinforcement ratio. It's not main reinforcing bar. Is it clear?
Yes, sensei.
Oh, any other question? Hi. Okay. I'll go ahead. Okay. Maybe I should explain the mechanism of thermal cracking. Okay. Okay. Can you see the slide?
Yes, Sensei.
Okay. So I have uploaded this PowerPoint file also to LMS. Okay. This PowerPoint file is the selected slice for one PhD work done by Dr. Mehboob Rasul from Pakistan, supervised by me. These are the committee members. The title of his doctoral dissertation was, sorry, I'll remove earphone. Can you hear me? 大丈夫?
はいはい。
Okay. The title of his doctoral dissertation was Prediction of Maximal Thermal Crack Width of RC Abutments and Investigation on Influential Factors using Artificial Neural Network. That was his doctoral dissertation. Okay. So his research was related to thermal cracking or thermal crack widths and abutment. So the targets are same in the first explanation. Okay. Here, maybe you can find that many influential factors are there. Okay, for cracking and also crack widths. Okay. This is not abutment. This is RC wall. Okay, an RC wall. I don't know for what the function of the structure, but anyway, for this long wall, thermal cracks have been generated. You can find a kind of water leakage. Okay. Anyway, in the case of Yamaguchi Prefecture, their target was abutment for bridges. Okay, but generally speaking, for massive structures, thermal cracking can happen. Okay, so engineers want to mitigate cracking. Okay, so this is a kind of schematic figure for bridge abutment. Okay? Again, this is footing, foundation, footing, and this vertical wall is constructed after the footing. In many cases, one vertical wall will be divided into 2 lifts or a third, 3 lifts, etc. After that, parapet will come. Upon this chair, the girder will be constructed. Okay, is it clear? はい。で、of course, we want to control cracking for durability and also for water tightness and sometimes for aesthetics. Okay, but it's a kind of construction management problem. Okay, can you guess the conflicts between owners and contractors? Can you imagine? Because it's very difficult to predict the occurrence of thermal cracking, or it's also very difficult to predict crack widths. That's why always conflicts. Okay. So if you are a contractor engineer, you have to repair a very large crack, of course. Okay. But is it your own responsibility? Okay. Many factors. That's why in some cases, original designs are very bad. Okay. So even when you do perfect concreting work, perfect construction, crack can happen. Okay. And crack widths can exceed the limit. Okay. So it's not so easy. That's why in that sense, it's a kind of construction management problem. Okay. Okay. So is it okay so far? So can you explain why thermal crack happen? Okay, I'll try to use whiteboard. I'm not sure it works or not. Okay. はい。大丈夫ですか？ Okay. For example, first lift of vertical wall of abutment on the footing. Okay. So something like that. Concrete wall, of course, it's a kind of prism shape, but it will be constructed upon. Can you see? 大丈夫？
Yes, yes.
はい、
Yes,
先生。
can see.
大丈夫ですか？ This lift of vertical wall will be constructed upon already hardened footing. Okay. Then, in some cases, cracks will be generated. Okay, like that. Right. So these crackings are a target. We want to mitigate. Okay, we want to prevent cracking, or we want to control the crack widths. Okay. I'll erase. Okay, it's not so easy to perfectly erase. So sometimes I would give you oral information. Okay, I already told you that these crackings are called thermal cracking. In Japanese, ondo hibiware. Okay, but of course, not only thermal deformation, but also, for example, drying shrinkage or etc. Many factors are included. Okay, but now I will very simply explain the mechanism of thermal cracking. Okay, can you see? can you see two axes? 大丈夫? Okay, I see. はい。Temperature. Can you see?
Yes, 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 sir.
Okay. はい。It's not the real condition, but I'll use a kind of ideal situation, okay? So now temperature, okay, starts from 0 degree and goes up to, for example, 20 degree. Sorry, it's thermal cracking, so sorry. 50 degree due to hydration. After that, come back to 0, okay? Then can you see this concrete member, concrete beam restrained by, with external restraint, okay? In this case, perfect restrainment, external restraint. So volume change of concrete is perfectly restrained, okay? Is it clear? Okay. So when this member is made of steel, what will happen? No hydration is already there, okay? So when you give temperature change, what will happen? I need to erase this model. So please check memo about this perfectly restrained model. I will erase, okay?
Volumetric expansion.
Then what will happen? Stress. So first in compression, then come back to 0, okay? This is compression, this is tension. Okay, it's clear. No residual stress. It's clear, right? So I will erase. The next, what will happen if that member is made of concrete? Okay. So at the starting time 0, it's fresh concrete, okay? So no strength and no Young modulus, okay? If we assume ideal condition, okay? So in the case of concrete, it's not linear, but it's something better. Okay, according to the passage of time, the hydration gradually proceeds. Okay, that's why in the stage of temperature rising period, Young modulus is very low. That's why compressive stress is very small. Okay, but on the other hand, in the temperature decreasing stage, Young modulus is very large. Okay, so this is tensile stress. That's why if the tensile stress of concrete exceeds strength, crack will happen. Okay? Is it clear?
Sensei, x axis wa time ですか?
Time.
Time, はい。
Time, okay. Okay? で、again, I need to go back to the perfect restraint model. So can you see this one? So it's similar to vertical wall on the footing. Okay, it's similar, but this is a kind of ideal model. Okay, so I hope you can see this model. So anyway, the vertical wall of abutment. This is the newest, latest structure. Okay. This vertical wall tries to expand due to temperature increase, or try to shrink, contract according to temperature decrease. Okay, the volume change is restrained by external structure. In this case, footing. Okay, if the volume change is not restrained at all, if it's free volume change, no stress is generated. So this is a kind of ideal modeling. Perfectly, the volume change is restrained. Okay. All right. So this will be the final explanation. So what are the influential, very important factors for cracking? First, volume change. Okay. Driving force on volume change is heat generation, temperature change, or as I told you already, drying shrinkage is also included, but many factors. Anyway, volume change. Okay. Okay, and external restraint. In this ideal model, 100% restraint, but it cannot happen in reality. So extent of external restraint is very, very difficult. Okay, external restraint. And also material properties like Young's modulus or strength. Okay, material properties. Okay, and finally, I have just explained about cracking, but what will happen after cracking? Crack width is also our concern. That's why reinforcement ratio, okay, rebar ratio, etc. Okay, so I will not explain anymore, but I explained very briefly about cracking and influential factors, etc. Okay, so in this very extremely brief explanation, already 4 factors. Okay, but for example, ambient temperature, environmental temperature, or sunlight, or quality of concrete construction. Okay, too many factors. Can you really control cracking? Can you really control crack width? Okay, so durability is not so easy. Okay, because our target is real structure. Okay, so far it's okay. I have to change the explanation. So if you have any questions, please. 大丈夫? Okay, I'll go ahead. Then, ちょっと待ってね。I'll go back to Dr. Rasul's presentation file, okay? Can you see this slide?
Yes, Sensei.
Okay. Okay. Again, our target is thermal cracking in our study. In the case of abutment for a bridge, upon the footing, vertical walls will be constructed. So there is a risk of thermal cracking in vertical wall or in the parapet wall. Okay. If you're interested, you can find this information later. Okay. So Dr. Rasul, Dr. Rasul from Lahore University, Pakistan, he utilized the construction database of Yamaguchi Prefecture for machine learning. He could use the data from the construction data like this. For example, cracking or not, or crack widths. The thickness of the structure like that, okay, or width of the structure like that, or height of the structure. Okay, according to the size of the structure, of course, the heat generation will be different. Okay, for massive structures, we can predict larger hydration heat. But you can imagine. Okay. Here, as I told you already, reinforcement ratio is also important. And this is concrete, so water to cement ratio, unit cement content, whether expansive additive is used or not, or fresh properties, initial concrete temperature. Now you are experiencing very cold season in Japan, okay? But in summer, very hot, okay? So hydration, heat or concrete material properties are affected by concrete temperature and also ambient temperature also, you can imagine, okay? Sorry, no need to understand all, but I just want you to feel how many influential factors are there, okay? Okay, what's lift interval, okay? Lift interval means that this abutment will be divided into several lifts. In this example, 4 lifts: first lift, second lift, third lift, and fourth final lift. So there must be some time interval between the first lift and second lift. Okay, it's called lift interval. So I taught you 4 influential factors in summary, okay, for cracking mechanism. Do you remember the one of the influential factors? Extent of external restraint. Do you remember? Okay, it's depend on this parameter, lift interval. Okay, for example, if the lift interval is only 3 days, I mean this second lift was constructed just 3 days after footing. In that case, footing is very weak, soft. Okay, Young modulus of footing is small. That's why extent of external restraint becomes small. Is it clear? But on the other hand, if the lift interval, time interval is, for example, 1 year, for example, it's too long. But if you suppose 1 year, the footing is completely hardened. So Young modulus of footing is very large. That's why extent of external restraint becomes too large, okay? Very large. So according to a lift time interval, the crack risk will be changed, okay? It's so complicated, but etc. So can you feel how difficult it is to control cracking, okay? Okay. yes, I will stop using this slide. I need to change the material. Any questions so far?
Sensei,
はい、ちょっと待って。
I just want to ask.
ちょっと待って。Please wait. はい。
I just want to ask about the meaning of the numbers on the previous slide.
Number?
Yeah,
OK.
the numbers on the table.
ちょっと待ってね。This one?
Yes, Sensei.
Okay, I see.
What's the meaning of
Okay,
two?
I see. OK. ちょっと待ってね。I'll explain. I have uploaded this material. ちょっと待ってね。Can you see this journal paper?
Yes, Sensei.
Okay, so this is his paper, okay, in journal paper. So same figure, okay, and neural network methodology is also explained. Maybe you know neural network, right? So his target was predicting maximum crack widths utilizing Yamaguchi Prefecture database. Okay. Then he succeeded in predicting utilizing that machine. He investigated the effects of inferential factors like cold weather, moderate weather, hot weather, or unit 7 content, etc. But anyway, if you're interested, you can study this one. Okay, then I'll go back to your question. Okay, so he used database. Okay, so for example, 248 was the number of lifts which he used, which he could use. Do you understand?
Yes,
but some information were missing among 248. That's why he could not use all, something like that. Do you understand?
Right.
Okay, so honestly, 200 or something are not large number for machine learning. So it was not easy to establish good machine utilizing only 200 or 250 number of data. That was his effort or struggle. はい。はい。Any other question? Okay, so I will go back to the first slide. Okay, this one, ACI forum slide. Okay, can you hear me?
はい。
大丈夫? Can you hear me?
Yes, Sensei.
Yes. Okay. So again, I will use this slide. Okay. Now you have some idea about how difficult it is to do control cracking. Okay, due to many inferential factors. Okay. はい。で、some of you, okay, belong to concrete research laboratory, our laboratory. Okay, so some of you know that we can use numerical simulation tool, okay, for predicting cracking or crack widths. You know, right? The level of numerical simulation technology in Japan is that, of course, by far the top in the world. Okay, but simulation is simulation. I will also use numerical simulation for my own research, but real structures are different, okay? So I will start the third section of today's scenario. Okay? Yamaguchi Prefecture, in their system, they didn't use numerical simulation at all. Okay? Hi. So it's okay, right? I'm already. So again, it is a review. So they wanted to control harmful cracks. Okay. Still now, you don't know the details of this check sheet. I'll tell you later. But anyway, according to their development, good concreting work can be done. Okay. Okay, I need to use this slide. Okay. So there is a database, good database, okay, of vertical wall lifts or parapet wall lifts, etc. Okay. Dr. Rasul could use 250 data for his machine learning. Okay. Again, the construction quality should be good. Okay. Otherwise, the data becomes garbage. Okay. Can you understand? So, of course, cracking is affected also by quality of concrete construction, quality of construction. Okay. So we have to eliminate the effect of poor quality construction. Okay. Even after we eliminate the effect of quality of construction, still there are many influential factors. Okay, like the size of structure or initial concrete temperature or environmental temperature, etc. Still many factors. Okay. So one of the point was that in Yamaguchi system was that they eliminated the effect of poor quality construction. Okay. Okay. Then what can they do? What could they do? In the stage of designing, they could refer the database, okay, past results of their own construction. Okay. Maybe you can imagine. Oh, from now we will start constructing one abutment. We can refer the past data with same size or same season, for example, etc. They can easily find that, in the past, same kind of similar structures, very large crack happen, for example, 0.3 millimeter, okay, etc. If they find such kind of information, what can you do? You can add reinforcing bar, for example, etc. They can do proper crack control design based on investigating the database. Okay. After that, again, they will construct. Of course, quality of construction is good. Then, again, that data is accumulated. Based on this database, we can establish a kind of guideline. Okay? Of course, they already have a very nice, sophisticated crack control guideline. It's updated, improved every year. Okay, etc. So can you imagine a kind of scheme of the system? So they do not need to use numerical simulation. Okay. Hi. Is okay? So, okay, ちょっとまた I will use whiteboard. きます。Can see? Okay. Now you are learning durability, right? Cracking is one of the components related to durability. Okay. Maybe I hope you are learning how difficult it is to achieve real durability. Okay. But I learned from the top engineer in the field of railway engineering. His name is Dr. Ishibashi. Please remember his name, Ishibashi. Okay. My Professor Maekawa also respects him a lot. Okay. I learned from him that please do not think durability in the same way as safety or serviceability. Okay, safety is much more important, okay, than durability, according to his explanation. Okay, serviceability is also important. For example, the deflection. For example, deflection of girder. If the deflection is too large, Shinkansen cannot run, right? For example. So safety problem or serviceability problem are much severer than durability problem. He explained like that, okay? But please do not understand that the durability problem is not important. He was not saying in that way, okay? Okay. So one of the reason, okay, one of the reason is that it's not so easy to how do I say predict durability performance correctly or accurately. Okay, it's very difficult, right? So from next week you will start learning seismic problem. Okay, structural performance can be more accurately predicted than durability. Maybe that's one of the reasons. Okay. Hi. So, but we can interrupt Dr. Ishibashi's explanation in this way also. Okay. So we should not depend too much on numerical simulation for durability problem. Now you can feel how dangerous it is to depend too much on numerical simulation. For example, cracking problem. You can imagine, right? And okay, I'll continue my explanation. So what will happen when cracks occur? Of course, it can cause a conflict between owner and contractor, but it's okay. But we can repair, right? We can repair, okay? So cracking is important, but it's a, how do I say? We should not put same priority on cracking as in safety problem, okay? Is okay? Hi. But I'm the specialist of crack control of concrete structures, okay? So it's also a big problem. Okay? There are too many conflicts, okay? It's a kind of human problem, okay? Sometimes, of course, cracking will cause severe deterioration, okay? So we cannot say that it's not important. Okay? It's also important, okay? But please, finally, okay? Please think in a different way, okay? That's my message. Both are important, okay? Hi. いいですか? Okay. So far, is it okay? Any question? Right. Okay. Then finally, I should explain how good concreting work, good quality construction can be achieved. Okay. ちょっと待ってください。Can you see this paper?
Yes, Sensei.
大丈夫。はい、OK。あちゃ。はい。So, I have uploaded this paper also to LMS. Okay. That title is directly related to this lecture. How can we achieve durability of concrete structures in very severe environment? Okay. At that time, I was an associate professor. はい。
It's nice, Sensei.
Pardon?
I say it's nice, Sensei.
Because I was promoted?
Yeah, it's nice.
まあちょっとSo, figure 1 is showing core joint, a kind of initial defects due to poor concreting construction. And figure 2 is showing a small honeycomb, okay, upon placement joint. Or figure 3 is showing settlement crack, okay, due to segregation, okay, etc. Okay. So we want to prevent these initial defects, and we want to achieve good concreting work. Okay. はい。で、ちょっと I need to explain this one. I already explained that the one check sheet was developed in Yamaguchi Prefecture. Okay. Let's see in detail. Sorry. Okay. So this sheet is shared among supervisor of the construction. I mean owners. Okay. Engineer, government engineer, for example, and contractors. Okay, they are sharing this check sheet. Okay, sorry, I'll stop. Japanese construction system is a bit different from my international system. Maybe some of you are learning from Kusayanagi sensei, Professor Kusayanagi. Okay, owners and contractors and construction manager, okay, CM, okay, to try a kind of triangle relationship. But in Japan, not like that, okay, owners and contractors, okay. So there is a kind of supervisor in the side of owners. For example, in government, the supervisor will supervise the construction, but something like that. Of course, inspector is also there, okay. Okay, I'll go back. So again, this sheet is shared among supervisors and contractors. Okay, what are written? Let's check. For example, here. すいません。はい。Totally 27 or 28 items are picked up in this one sheet. Okay. For example, okay. For example, here, sorry, it's a bit small, but for example, in the placement stage, concrete should be appropriately placed so that the surface becomes flat. Okay. Again, concrete should be appropriately placed so that the surface becomes flat. Okay. コンクリートは水平に打ち込まれているか。If this fundamental matter is followed in the site, okay, what will happen? Do you remember this one? This kinds of, how do I say, inclined placement joint can never happen. Okay, if we follow that rule, okay, concrete placement should be flat. Okay, so this initial defect is showing that the very fundamental basic matters, basic rules are not followed, okay, in the real construction. This is the evidence, okay? Let's go back. For example, during compaction, this one, internal vibrators are inserted about 10 centimeters into the lower layer of concrete. Do you understand the meaning? I'll use whiteboard again. Do you understand the meaning? Yes. Destroyed. My system, temporary system is destroyed. ちょっと待って。Can you see my whiteboard? すいません。あれ、こうか。はい。Okay. Suppose we are making one lift of vertical wall, okay? For example, the height is 3.5 meters, for example. Do you understand? One lift height is 3.5 meters. But we have to divide one lift into several layers, okay? For example, 50 centimeters. Like that, okay? So, second layer, sorry, this is flat. So, I'm bit English, sorry, okay? Like that. はい。で、first layer is finished. Second layer is also finished. So please assume that now you are constructing the third layer. Okay? Fresh concrete is poured. Then that rule means that the internal vibrator, the head of the vibrator, 10 centimeters, should be inserted into the second layer. Okay? That's the meaning of that rule. Okay? The operator is here. How can you confirm that the 10 centimeters head of the vibrator is in the second layer? You cannot see. Okay? But it's specified in the code. How can you confirm? Okay. In your country, are you really checking? You are not checking. That's why poor quality concrete structures are there. Okay. Then I'll go back to that. Again, let me confirm that rule. Sorry, compaction. Can you see this one? Internal vibrators should be inserted about 10 centimeters into the lower layer of concrete. Okay. Please look at this picture. Can you see this one? I should magnify. Can you see? Okay. This is the vibrator workman in one construction site. Actually, this structure was in Yokohama City. Okay. This picture was taken by me, by myself. Okay. Can you see a red tape here in white circle? Can you see?
Yes, sir. Yes, sir.
Okay. So red vinyl tape to check the inserting depths of vibrator. Okay. So the contractors prepared in that way. Okay. So please remember this red tape. Okay. Again, I'll go back to the whiteboard. Okay, in that case, in that picture, they put a kind of red tape, okay, here. So they can check the height of this red, sorry, this is green, but red tape at the top level of the placement. So they can check the height of the tape near his hand, okay? So by checking the height of this red tape, they can confirm that the head of the vibrator is in the second layer. Of course, they need to control the height of each layer appropriately. Okay.
Sensor in the.
Okay, I will add one more information. Okay, so this is just one example, but if you want to how to say follow the basic rules in the specification, you need to prepare appropriately, like this example. This is just one example. I think there are many other ways or methods to satisfy the requirement. Okay, do you understand? So that one page check sheet promoted the nice preparation by contractors, okay, etc. So on the other hand, not on the other hand, in the same way, so no, sorry, on the other hand, supervisor could easily check the quality of concrete, okay, if the preparations are nice, okay. Only one sheet, but it changed the construction site. Okay. But this is another way to achieve durability. Okay. In the first lecture of my, in the first day of my lecture, I explained self-compacting concrete. Okay. So that's not dependent on the skill of workers. Okay. But this is another way. So we should prepare several or many ways for durable structures.
Sensei, on the...
ちょっと待って。Question?
If I just want to check, just like as inspector, if I just want to check the exact depthness with that red tape. So on some horizontal section which you just have shown in the picture, maybe the picture which you have just taken from the side. So what's basically the exact distance from one check to other check? What the code say in that thing?
Sorry, I don't understand. One check? What do you mean by one check?
I mean that if you just check at 1 meter, so now the other checkpoint will be on the 2 meter, on the 3 meter, or the somewhere else. The distance between them, what the code say in that, because maybe.
Sorry, your question is not clear. What do you mean by 2 meters or 3 meters? I explained 10 centimeters, and each layer was 50 centimeters. So I don't catch your point, sorry.
Actually, I just want to know the distance between two checks.
Two checks? Not clear. Distance between two checks?
Maybe the irregularity is not uniform, like of the concrete placement is not so regular. If I just see that on x-axis, so maybe on the 1 unit of x, and maybe there's some check on after 5 unit of x-axis. So the distance between two checks.
I cannot totally understand the question. Sorry.
Okay.
I'm sorry.
I will just draw some picture and then email you, and maybe.
Oh, yes, please.
Okay.
Oh, I cannot understand at all. Sorry. Any other question?
Sensei.
Yes.
This means the previous part when we in the concrete is not totally hardened. It's getting hardened. I mean, when we pouring.
Okay, I see. This one?
Hi.
Of course, the time interval for each layer should be shortened. As much as possible. Otherwise, the previous layer is hardened.
Hi, I think so.
It will cause cord joint. It's called cord joint. You should prevent such kind of situation.
So as soon as possible
yes.
Hi.
Yes.
Sensei?
Yes.
Well, I would like to know I mean the depth of vibrator is about 10 centimeter is set. What if it more than 10 centimeter, like 20 centimeter or 30 centimeter is problem?
I see. Okay. I will tell you several information, okay? It's a kind of maniac knowledge, but maybe it's important to achieve good quality concrete, okay? Yeah. First of all, okay, according to our experiences or according to past my investigation, maybe 10 centimeters is enough to unite two layers. Okay, no need to put 20 centimeters. The objective is to eliminate butt joint, right? To unite two layers. So I think 10 centimeters is enough, okay?
Yes.
The second information is very maniac, but I learned recently, okay? Okay, can I tell you very maniac knowledge? So suppose this is vibrator, okay? I can see? Okay.
Yes.
The vibrator is effective in horizontal direction. It's said that the effective area, of course, it depends on the diameter of the vibrator. Roughly speaking, it's around 300 millimeter in the horizontal direction. Okay? But it's not so effective in vertical direction.
Oh, I see.
Okay? So that's why the spacing of the location of each vibration should be less than 500 millimeter. It's also specified in the code. maybe it comes from this effective area, okay?
Yes.
But, sorry, honestly, it's not long like. So you should take care about this portion where the vibrating is not effective in vertical direction. Okay, so if you concentrate too much on this uniting, the vibrating in the upper portion becomes poor. That's why air bubble sometimes cannot be eliminated, etc. So yes. I recently learned this knowledge. Yes, not yesterday. 2 days ago, I was in a construction site to supervise government site. I told this knowledge to them.
Yeah, thank you, Sensei.
No need to remember this kind of maniac knowledge, but the point is that yes, basic rules or fundamental rules in the specification are not followed in the site. Okay, so we have to think about a system. Okay, I didn't explain all the items in the check sheet, but I can supervise this site. So of course I have much more knowledge. Okay, I showed only several examples here, but you can think about different system. But but if we want to follow the same kind of system, I think you can easily apply this one in your country also. Okay. And 10 minutes more. So can I add one more information or any question? Hi. OK。ちょっと待ってください。OK。Final information. OK。Can you see this paper? Can you see?
Yes, Sensei.
OK。ちょっと待ってください。はい。ちょっとI will try to explain. So I have briefly explained about check sheet, okay, for concrete construction. But we have one very simple, easy evaluation tool. Okay, I'll explain this one. It's called visual evaluation method. Visual evaluation method by naked eyes. I am also one of the developers, and we got a prize from Japan Concrete Institute. Okay. This one, I'll make it small. This kind of sheet, again, a one-page sheet. Okay. This is used for visual evaluation method. Okay. Okay. If the quality of construction, if the quality of concreting work is poor, okay, you can find the evidence on the surface of concrete. You can observe the evidence of poor construction on the surface of concrete. Okay, so concrete is honest. Concrete is a kind of teacher to you. Okay, if the human system is poor, if the human system is stupid, if some workers are lazy, if you supervisor is lazy, okay, if the contractor is system bad, okay, honest concrete shows the evidence, okay, like settlement crack, like a surface air bubble due to poor compaction, or cold joint, or not horizontal joint, or leakage of cement paste from the joints of the form, or sun streaking like that, okay? So check-in after removing form is also effective, okay? So this is not inspection, a kind of quality control, but if you find some problems, you can feed it back to next construction. Okay, in the case of abutment, there are 4 or 5 lifts, right? So in the first lift, footing will be embedded into underground. So it's okay. If you can find some problems, you can feed it back to vertical walls construction or parapet wall construction. Upper portion is much more important from the viewpoint of durability, okay? So we have also developed this kind of simple tool, okay? This can also be utilized in your country also, okay? Any question? So combination of preparation check sheet and evaluation tool, the quality can be improved drastically, okay? So I'll show you, sorry, one example, okay? Can you see this one? If you're interested, you can refer this paper later. So before improvement, after improvement, so improvement of quality of cover concrete due to PDCA system, okay? So this is visual comparison, but according to that visual evaluation method, we can quantitatively evaluate. The 4 point is the maximum, okay? So this is the comparison in the same structure, number 1, first lift, and 5th, final lift, okay? So core joint was improved, and leakage of cement paste from the joints are also improved, okay? Finally, in the final lift, almost perfect quality, okay? Like that. Hi. So, in the very large number of construction projects in Tohoku, after the disaster in 2011, it's almost 10 years ago, okay? Very large number of bridges or tunnels have been constructed. I'm deeply involved in the supervising those government projects, okay? So that's check sheet and also visual evaluation method sheet are fully implemented in the real system. Okay? I am the person who knows the best about that system, okay? So there are many kinds of research, okay? So very, very scientific research. I'm very practical engineer, so please learn many philosophies or many things from many professors, okay? Is that okay? Whiteboard was effective.
Yes. Yes, sensei. Thanks for that.
Any question? That's all from me. This is the end of durability design lecture. Okay. Any question?
Then it means the visual evolution method at the table. The sensei show us. This means it is unacceptable cracks, so it should be repaired, right? But sensei also mentioned about the conflict between owner and construction.
Okay. No. about that table of visual evaluation method? Okay, so I should explain more, okay? So, there is an inspection for each construction, okay? If the structure cannot pass the inspection, they have to repair, okay? But even for the structures which passed the inspection, there's a variety in terms of durability quality. Okay, some contain more air bubble. Some contain minor settlement cracks. Some contain a small, slight core joint, for example, but they passed the inspection. Okay? So I should say that the inspection system was not good in terms of durability. Inspection system is still not sufficient for constructing durable structures. Okay? So visual evaluation method is not inspection, but now we are utilizing as a kind of quality improvement. It's not quality control, quality improvement or quality attainment to brush up, to improve the quality to sufficient level. Okay?
Quality assurance, we can say that.
Is it clear? So durability is not, but durability system is not established yet. Oh. Is it clear?
Hi, Sensei. Hi, in the construction process, it should be past inspections. But after that, the durability state is another level. So maybe,
yes.
Maybe after past inspection, some cracks can be occur after.
Yes. Durability system, durability design, durability inspection, and good concreting work, those matters related to durability are not matured. It's okay? Immatured, not matured. That's why we are improving. Please understand in that way.
Hi, Sensei.
Okay. Oh, right. So in your country also, take care. Okay. You want rapid construction. Okay. You want cheap infrastructure. Okay. They don't think about durability. Okay. So in the future, you will face serious problems. Like our disease. Okay. Drinking too much, eating too much, you are alive, but if you think about your durability of your human body, okay, we have to take care, right? It's very difficult to control our appetite. Okay, right. But durability is something later. That's why it's difficult. Okay. Safety problem like seismic damage. If we how to say use analogy, you always take care about traffic accident, right? It's safety problem. Okay. But durability is always difficult in many senses, right? So it's okay. It's time. So sorry. Let me explain this paper. Sorry. Sorry. あれすいません。Can you see this paper? Can you?
Yes.
Yes. Okay. Next week, I will start explanation about this paper. Okay. The first author is Dr. Ishibashi. I told you in today's lecture. Top engineer in the field of railway engineering in Japan. Okay. So no need to read through, but please briefly look through the paper if you're interested, okay? So it contains seismic damage and how to retrofit, or the philosophy of seismic design, etc. So it's a good material to start the second part of my lecture related to seismic design. Okay, I already uploaded. Okay, はい、じゃあ、next week, next time is the last time in this year, in this difficult COVID year. はい、じゃあ see you next week. Bye bye.
Thank you, Sensei.
はい。
Thank you, Sensei.
はい